Namaste and welcome in this learning platform. It's me Amin Basnet, scholar in STEM education. According to course facilitator instructions, this presentation video is prepared under the course title EDST 509 Data Analytics for STEM Educators. And the topic of today's presentation is Skewness and Kurtosis, Understanding Distribution Shapes. And the objectives to prepare this video is, after watching this video, learners will have ideas of basic concepts of skewness and kurtosis, identify different distribution shapes, and interpret what these measures say about real-world data. Along with this, we'll move to the Jamobi and we'll upload some data from technological acceptance in higher education, and we will see the values of skewness and kurtosis, as well as we will see distribution shapes of skewness and kurtosis too. Now here we go in skewness and kurtosis. Let's see the distribution shapes. Here the distribution shapes are provided. When we analyze data, average like the mean don't tell the whole story. To truly understand data, we must look at its shape. Two important measures that describe shapes are skewness and kurtosis. Like in skewness, here normal distribution, yeah, and as well right skewed, as well left skewed, where we see in the right skewed long right tail, in left skewed long left tail, and in this left skewed mean is less than median, and in the right skewed mean is greater than median. This we can observe here visually, as well as in kurtosis this mesocotic, yeah, where in this mesocotic kurtosis is 3, means data is normally distributed, and on the remaining we have two curves, that is leptocotic, yeah, where a kurtosis k value is greater than 3, and platocotic kurtosis value k is less than 3. Now, let's go to the introduction to skewness. Actually, skewness measures the asymmetry of the data distribution and helps us to understand how values are spread around the mean. Now, here, if we see normal distribution, left hand, the right sides are mirror images. Means mean is equal to median, or mean is approximately equal to median. Also, we can see. And here, if the difference between mean and median is up to 5%, then we can say that that is normal distribution. If more than that, then that will be either left skewed or right skewed. And left skewed we call we see here long left tail, and in right skewed here we see long right tail. Now, general rule here for mean median rule of skewness, a data set is said to be skewed if the difference between the mean and the median is more than 5%. And one example I have shown here, if mean is greater than median, that is positively skewed here, and if mean is less than median, negatively skewed. And if the difference is less than equal to 5%, data is considered approximately symmetrical. But some important note also I have kept here. This should be seen nicely. And for formal measures, we include Carl Pearson's, Bollige's, and Kelly and Fisher's method too. Okay, just this is the rule of thumb, not a formal coefficient. And one simple numerical example also I have shown here, and we find here 6.67%. And what the conclusion we are giving here is, since the difference is more than 5%, data is skewed. Yeah. Now with this skewed data here, mean is greater than median, so the distribution is positively skewed. And as well here, what we can say is that these extreme values pulls the mean to the right and makes the mean greater than the median. That we have to know. And one real world example of right skewed, we can say that in a company, salaries distribution is usually right skewed because a small number of top executives on very high salaries, yeah, that we can see in different companies. This is the one real world example of right skewed. Now, introduction to kurtosis. Kurtosis actually measure the peak or height of the data distribution and helps us to understand the shape of frequency distribution. And we see here visually the types of kurtosis too. Yeah, first mesocotic. Well, k value is 3. There we keep here the reference value of kurtosis 3. Means if k is equal to 3, normal distribution, data is distributed normally, and if less than 3, platycotic, and if greater than 3, leptocotic. Now, moving to the next slide. There are type of kurtosis. First, let's discuss on mesocortic. In this mesocortic, we find the moderate peak, yeah, normal distribution, and leptocortic here sharp peak we find, yeah, more extreme values are there, and in platocortic, flat peak or light tails we find. And to check normality, we use the values like skewness, kurtosis, and normal probability plot or histogram. This we use, and after this, I'll move to the Jamovi software. There, I'll upload the data of technology acceptance in higher education, and we will. I'll go practically. I'll practically show the skewness kurtosis values and different distribution shapes. Now let's go to the Jamovi. Here, I go to Jamovi. I have uploaded the data of technology acceptance in higher education in Jamovi. Now, after uploading data, it looks like this. Now here we see the different variable, university role, gender, academic level, like that. But here in today's video, just we'll go through the numeric data only. Here exploration, I go to exploration, I go to descriptives. Now in the descriptives here, let's have a look on the readiness variable, and in the same way we can have the static score. Let's see static score, and let's see the research score. Okay, here we have mean, median already checked, and standard. When mean and median standards deviation we must see, because standard deviation it gives the how much the data is spread. We see through the standard deviation. Now our main agenda is skewness and kurtosis. Let's check the skewness and kurtosis, and along with this, let's see the normality too. So the Shapiro week. Now through the skewness and kurtosis, data are normally distributed or not. That is our main agenda in today's today's resource video. In this resource video, now here let's see through the visual diagram. Okay, now here our total number of respondents are 248, and mean value we see here. Median standard deviation we see. Standard deviation, if we see the standard deviation is start score and research score, they are somehow spread more as compared to readiness. And now here yes, now skewness value we see and kurtosis value we see. They are in the range. I think they are in the range. Now let's check down here. Readiness average, or somehow it normally distributed. Start score also somehow normally distributed. Let's see by the later on value. Research score also somehow normally distributed. Now to check this, let's see here one skewness and kurtosis, they must be in the range of plus minus 0.5. Yeah, now this means normality check using skewness and kurtosis. Skewness and kurtosis value we see here. And now yeah, from above table we have skewness is 0.0288 and kurtosis minus 0.243. These two value lies between minus 0.5 plus 0.5. Means in such a case, score of research subject are normally distributed. We can say as well as yeah, if we divide skewness by standard error of skewness, the values are less than 1.96. Yeah, and we can say that data is normally distributed, yeah, through both skewness and kurtosis. Okay, in the same way, let's check the skewness and kurtosis of start score. Start score also we find within the range, and the statistics, the scores of statistics are also normally distributed, and less than 1.96 that are normally distributed. It's okay. Now let's check of age. If we check age, let's see the shape of age here. If we check age, what we will see, oh, here, right skewed. We see the extreme values are here. This is the data are not normally distributed. From the visual diagram we can see. Okay, thank you, and see you again in another resource video.